And it's going to depend on the distance in between. And here was the problem, is when you're calculating the distance between the Earth and the Moon, it really depends on which point you pick. So here's a point on the Earth, and there's a point on the Moon. And there's a certain distance there. And here's a different point on the Earth, and a different point on the Moon. And that's a different distance. How many distances does Newton have to worry about? Infinitely many. So do you guys have physics yet? Enough physics to know the trick for this? What he did? He said it would be exactly the same gravitational force if we just concentrated the entire mass of the Earth into one point, the entire mass of the Moon into another point, it's actually the centroid, by the way, and then for the distance calculation, just do this one single distance. So the gravitational force measured with just v, which was this distance, is going to be the same as all the distances that you would measure here. So we've got a similar problem for this example. We've got all these different distances. We've got infinitely many distances from y equals 0. And we're going to follow Newton. And we're going to collapse this whole mess into a point mass, into one just at the center. So if this distance is y, which is right there, if I collapsed it all to the center, how tall is that? So the middle would be at y over 2. So again, you're thinking about all these different distances. When you have different distances, what you want to actually use is the average distance from y equals 0. So the average distance from y equals 0 is y over 2. And is this a dx or a dy? Dx. The area is going to be the base times the height. So the area is going to be y times dx. You see the clash here. So I'm going to go clean up over there. You are going to fix the integrand. You're going to convert it all to x's. Then you're going to use this to put in the numerator up there. An integral, and my y is given by x minus x cubed. So I just took this y, replaced it by its definition, and y again is x minus x cubed dx. And that dx is telling me it's x values that give me an x. Each slice is determined by an x value, and those range of x values are 0. That's kind of amazing is, not only do I get to have most of the fun, is I get to work out the problems and just follow along, but they actually pay me for that. So I'm going to let you have the fun on this one. This is what I originally had in my notes. Oh, and by the way, this is my last example. So what are we going to do? We still have, it's like half an hour into the class. We have almost, what, 2 hours left? Close to 2 hours, hour and a half. So what are we going to do for that extra hour and a half? Yeah, exactly. So what I'm going to do is I'm going to just talk about all the different types of problems you need to do for the exam. I'll work out 1 or 2 for myself. We'll just kind of, I'll show you quickly, I'll do a quick reminder how to do it. And then I'll give you a problem, and you'll try to do it yourself, and then we'll talk about the solutions. Yeah, absolutely. Yeah, so yeah, if you're working on homework, you have any homework questions, yeah. show you the graphs. So the parabola is 4 minus x squared. The line is x plus 2. One of those intersection points is negative 2, 0. And another intersection point is 1. The x-bar calculation should be straightforward. There's nothing new on this one. What I want you to practice is what we just talked about, how to do a y-bar